Hello friends, in this session we will be taking up the sum of arithmetic progressions, and we'll also be talking about arithmetic means and some properties of the arithmetic progression. Let's now talk about the sum of n terms of an AP. Now let's take an AP with n terms where A is its first term and D is the common term and L being the last term. Let's denote the sum by Sn. Now we know that Sn is equal to the first term plus second term plus third term till the last term, which is a plus n minus 1 d. Writing it in reverse order, we can write it the last term first, then the second last term till the first term. So now if we add the first and second, we get 2Sn is equal to 2a plus n minus 1d, because this added with this gives us 2a plus n minus 1d. This added with this will also give us 2a plus n minus 1d. This will be n times added. So we could say that 2 times of Sn is equal to n into 2a plus n minus 1 into d. So Sn is equal to n by 2 into 2a plus n minus 1 d. And now we know that a plus n minus 1 d is nothing but L, which is the last term. So it can also be written as n by 2 into the first term plus n by 2 into the sum of the first and the last term of the AP. That gives us the sum of n terms of the AP. Now the nth term of a sequence can be determined by using the formula an is equal to Sn minus 1. Obviously we know that the Sn is the sum of n terms of an AP. Sn minus 1 is the sum of n minus 1 terms of an AP. So if we subtract Sn minus 1 from Sn, we'll get the nth term. The same can be used to find the general term an of an AP if the formula of Sn is given to us. So we're not saying that the value of Sn is given, but if the formula of Sn is given to us, then we can use this and subtract Sn minus 1 and we'll get the general term of an AP. Now sequence is an AP if, this means if and only if the sum of its n terms is in the form Sn equal to an square plus bn, which means it's a quadratic expression in n. Quadratic expression in n, where a and b are constants. In such a case, the common difference of the AP is 2a, where a is the coefficient of n square. Now let's see how do we do that. Sn is equal to an square plus bn. This is given to us. So Sn minus 1 will become a into n minus 1 whole square plus b into n minus 1. Now we know that an is equal to Sn minus 1. So we subtract this from this. We get an is equal to an square plus bn minus a into n minus 1 whole square plus b into n minus 1, which gives us 2an. This nth term of an AP becomes 2an plus b minus a, because this is an square here cancels out. We have an a here and we have 2an remaining here with a minus sign and a minus here, so it becomes 2an here, and bn cancels with bn and a b remains here. So we have nth term is equal to an 2an plus b minus a. And now we know that if the nth term is represented as a linear expression in n, then the coefficient of n is the common difference, which is 2a. So an plus 1 is equal to 2a into n plus 1 plus b minus a, and then we subtract this and we get 2a. And we anyways know this, that if nth term is a linear expression in n, then the coefficient of n is the common difference. So simply using that, we get the common difference to be 2a. So sequence is an AP if and only if the sum of the n terms is of the form an square plus bn, which is a quadratic expression in n, and then the common difference of that AP would be 2a. Now let's talk about properties of an AP. If a constant is added to each term of an AP, then the resulting sequence is also an AP with the same common difference. Now let's see. If we have the AP 1, 3, 5, 7 and so on, and if I add a constant to each of these, say the constant is 4, so this becomes 5, this becomes 7, this becomes 9, this becomes 11, and this is also an AP with the common difference remaining 2. And the reason is simple, because this was first term is a, and here we have made the first term to be a plus k. Here the second term was a plus d, and the second term here has become a plus k plus d. So if we subtract its second term, its first term from the second term, the difference remains, the common difference remains the same, which is d. If a non-zero constant is multiplied or divided to each term of an AP, then the resulting sequence is again an AP, but the common difference this time becomes either dk or d by k, depending upon whether you've multiplied it or divided it. Now that can be again seen using the same sequence. If we multiply this with say k, the first terms become ak and the second term become a plus d into k. Now if we subtract ak from this, we get dk as the common difference. Similar would be the case if we divide, it becomes a by k and the second terms become a plus d by k, and if we subtract the first from the second term, we get the common difference to be d by k, but it still remains an AP. If a finite AP, the sum of the terms equidistant from the beginning and end is always the same, and it is equal to the sum of the first and the last term. So we are saying the first term is a, the last term is say a plus n minus 1d. The second term is a plus d. Second term from the last is a plus n minus 2d. So if we add the first and the last term, we get 2a plus n minus 1d. And if we add these two terms, we again get 2a plus n minus 1 into d. So this is same as what we did in the while we were trying to find out the formula for the sum of an AP. So this is how we are saying that the sum of the terms which are equidistant from the beginning and end is always the same, and this is equal to the sum of the first and the last term. Continuing with properties of AP, three numbers ABC are in AP if and only if 2b is equal to a plus c, because clearly c is equal to b plus d, which is also equal to a plus 2d. So if we are saying if we calculate a plus c, this becomes equal to a plus 2d, which is nothing but 2 times of a plus d, which is 2 times of b. A sequence is an AP if the nth term is a linear expression of n, and in such cases the common difference is the coefficient of n. We've already talked about it. A sequence is an AP if and only if the sum of its n terms is of the form Sn equal to an square plus bn, which is a quadratic expression in n, where a and b are constants. In such a case, the common difference of this AP would be 2a. If the terms of an AP are chosen at regular intervals, they also form an AP. What does that mean? If we choose A1, A5, A9 and so on. This will also form an AP. Regular interval means if we are choosing every fourth term of the given AP. Given AP was A1, A2, A3, A4, A5 and so on. But now we are choosing every fourth term of the AP. This would also be an AP, and the common difference obviously would be 4 times the common difference of the original AP. So the common difference will change, but it will form an AP. If an plus 1, an plus 2 are 3 consecutive terms of an AP, then 2 times of an plus 1 will be equal to an plus 2, which is similar to what we said here. 3 numbers which are in AP, or we are saying 3 consecutive terms of an AP, then twice the middle term will be equal to the sum of the other 2 terms. So friends, now let's understand what do we mean by arithmetic means in an AP. If we have to insert n quantities, capital A1, A2, A3 till capital AN, between two given numbers which are A and B, such that A1, A2, A3 till AN, B, this forms an AP, then all these quantities, these n quantities that we've inserted, are called the arithmetic means between A and B. Now, if single AM is to be inserted between A and B, then it is given by A plus B by 2, because simply we said that, if we have 3 numbers, 3 consecutive terms of an AP, we know that twice the middle term is equal to the sum of the other 2 terms. So just using that, we are saying the arithmetic mean, the only arithmetic mean that we are inserting, will become the middle term of the AP. So that will be equal to the sum of the other 2 terms, which are A and B, divided by 2. If we have to insert n AMs, then this AN will be equal to the first term A plus n into B minus A by n plus 1. So using this formula, we can find out the first arithmetic mean, the second arithmetic mean, and so on. Let's see how do we reach this formula. So we are saying n terms have been inserted. So that means A, and then we have these n terms, and then B. So we have a total AP of n plus 2 terms. So B becomes the n plus 2th term of this AP. So B will be equal to A plus n minus 1 into D. So we can say D is equal to B minus A into A upon n plus 1. So this is the common difference. Now if we have to find any arithmetic mean, let's say nth arithmetic mean, we know that the position of this nth arithmetic mean is n plus 1, because A is there, the first thing, and then we have this as the nth term after A. So this becomes the n plus 1th term of the AP. So AN becomes A plus n into D. So we put this value of D here, and we get AN is equal to A plus n into B minus A divided by n plus 1. Using this formula, we can find out all the arithmetic means that have to be inserted between A and B. Now let's look at an example question of arithmetic progression. We want to find out the general term of an AP whose 6th term is 12 and 8th term is 22. So we can say A plus 5D is equal to 12 and A plus 7D is given to be 22. So if we subtract this from the second one, we get 2D is equal to 10, which means D is equal to 5. And if we put this value of D here, we get A plus 5 into 5, which is 25, equal to 12. So giving us a is equal to minus 13. So now the general term, which is an, is equal to a, which is minus 13, plus n minus 1 into d, which is 5. So we get minus 13 minus 5, that is minus 18. So it becomes 5n minus 18 is the general term of this AP. So let's take up another example question. The sum of 4th and 8th term of an AP is 24. That of 6th and 10th term is 34. We want to find out the first term and the common difference. Now here the 4th term is a plus 3d plus the 8th term, which is a plus 7d. This is given to be 24. So we can say 2a plus 10d is equal to 24. In the second case, the 6th term, which is a plus 5d, plus the 10th term, which is a plus 9d, is given to be 34. So this implies that 2a plus 14d is equal to 34. Now we subtract this first one from the second and we get 4d is equal to 10, which would mean d is equal to 2.5. Now we can put this value of d in the first one. That gives us 2a plus 25 is equal to 24, which would mean a is equal to minus 0.5. So we know this is the first term of the AP and this is the common difference of this AP. So now let's look at the next example question. We need to insert 5 arithmetic means between 8 and 26. So we have 8, then we have 5 arithmetic means which we need to insert. So let's take them to be A1, A2, A3, A4, A5, and then we have 26. So now we know that 26 is the 7th term. So it becomes 26 is equal to 8 plus n minus 1, which is 6 into d. So we can say 6d is equal to 18 and we get d is equal to 3. Now just using a1 is the second term, which becomes a plus d. So a1 is equal to 11, a2 becomes 14, a3 becomes 17, a4 becomes 20, and a5 becomes 23. So we could also use that formula where we knew that nth term a and nth mean is given by a, which is 8, plus n, which is 5, into b minus a, which is 18, divided by n plus 1, which is 6. So this gives us 3, which means 8 plus 15 equal to 23. So we could use this formula also for finding out the 5th arithmetic mean. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.